Hello everyone, today we'll be going over the system design course. Today we'll be focusing on the historical context of relational and document models and databases. So, to be able to give a breakdown, we are going to be diving into the annals of database history, where we encounter a long-standing debate between the differences of relational versus document. For when we are exploring the context between different databases, relational versus document databases stand out between each other because the relational model has solidified with SQL and was very revolutionary against another debate in the 1970s. So, relational databases solidified an earlier debate in the 1970s because data could be organized into tables. And we typically, a good database would be SQL. I'll just put an example over here. So with the concept of how data could be organized into tables with rows and columns, we're able to actually understand more about how our data can be orchestrated. For in the 1970s, there was a committee called the Conference on Data System Languages, also known as CODA-SEAL, and implemented by several different database vendors. They also had their own model called the CODA-SIL model. The CODA-SIL model was a generalization of the hierarchical model. It was considered a tree structure with parents and nodes where the nodes represented records. In the network model, a record, however, there was a secondary one, dairy model, was also known as the network. Model, a record could have multiple parents. Could have multiple parents. For example, there would be one record. Network model could also be another example of the greater Seattle area. And then the greater Seattle area would be the parent, and then the nodes would equal different addresses. And every user who lived in that region will be linked to it. And this allowed many-to-one and many-to-many relationships to be molded. Allowed many one-to-one and many-to-many relationships. to be molded. And a query with codalist, codicil, was performed by moving a cursor through the database by iterating over lists of records and following access paths. If a record had multiple parents, multiple pointers, a record with multiple parents the application code must keep track of every relationship. And as you can tell, this would actually lead to very complex computational problems if you're keeping track of every single relationship instead of organizing the data accordingly. For even codicil committee members admitted that this was like navigating around a n-dimensional data space, meaning that complexity would constantly increase over time. So time, complexity would increase over time in n dimensions. An n-dimension data space. And to clarify what n-dimension is, it's also referring to big O notation as well. For the more complex, for instance, a software or algorithm is already set up in place and has to go through n number of iterations, the greater the computational time and complexity. And so there will be a video in the future about big O notation, but right now, the point of it, just to communicate it, is that codicil models, and especially the network model, since it had to keep track of every single relationship, was considered complex by nature, and there had to be a better alternative. And this is where the relational model would eventually come to play. So let me just go over to this picture. This in of itself would be considered the network model that we have over here. Notice the parent, that we also have to keep track of every single relationship that we have, and each parent would also be considered for every record that we are already inserting in. And then this is also the relational model, and this is just the document model, but I'm going to be going further in depth onto them. So the relational model laid out the data in the table as specified before by rows and columns, and there was no nesting of structured data. We can take a look at the picture over here. For we notice in particular is always associated with an ID, and that ID is already associated with the customer name, status, and you're able to extrapolate just based on one parent. So in of itself, it's kind of like taking the network model and putting it inside of a table, so you could be able to have tuples or rows and columns as well to indicate that one specific ID, therefore making it more efficient and less computationally expensive. Let's put this right here for reference. More efficient. And less computationally computationally expensive. And one could actually read any or all the rows of the table, selecting those that would match with an arbitrary condition. And one can read a particular row by designating some columns as a key and matching them with a pair. So one could be able to figure out between the rows and tables. And this is also going in line with data structures and algorithms, where one could apply a map or a tree to be able to actually search through the database that they have. In relational databases, the query is optimized. Queries in relational databases are optimized and provide access paths for specific data inquiries. Meanwhile, when we're going over the document model, I'm just going to use a different color. We'll just stick with okay. In a document model, a vivid example would be JSON, where we're able to have nested records and allow easier retrieval of specific components within the document and allows expansion of unstructured data. Like for instance, if we were to go up, I'm just going to go over to the document model example. So this is a document model for an HTML file. So HTML file is going to be having a backbone between a head, title, and other headings, and also paragraphs that one would be able to implement and ever expand between their HTML file. An HTML file is basically just the skeleton of a web page. And people can customize their websites any way they like, with custom titles, the amount of paragraphs, etc., and then also apply with their CSS for styling and JavaScript for functionality. Let me just expand upon these to make this bigger. There we go. HTML document, example of a document model, which is a skeleton of a web page. That's what an HTML is. People can customize. So I'm just going to make this red. go. All right, let me see if I can further expand this as well. Okay. And so, yes, this is the historical context for relational and document models, even in the context between the history that was already present with developing document models by going back on the codicil model, and also understanding the nature between its hierarchy as specified in the image over here, and then also the differences between the relational model and then also the document model as well. And I will have the notes already in the description for folks to be able to download out of their own time as well. So yes. Now to solidify our concept, let's go over an example. So let's focus on imagining a simple application for managing a library, inventory, and patrons. So we have a library and we are managing an inventory of books and patrons. In the relational database, we will see patrons, books, checked in and out, all organized in a table with their respected IDs. And can have multiple tables depending on domain and context. So if we were to consider a document-based database, each document could have details of their checked out book, such as, for instance, if I were to go over, like, let's just say that this is a JSON data, so we can have a book title. We'll just call it The Lamb, and this is a string. Then we could have checked in, like August 13, 2023 and checked out at August 20th, 2023. And that could be a string as well. Always remember your data types, depending on like exactly what you need in particular. And they're always separated by commas to be able to start. And then we'll have our semicolon here. So that could actually serve as a document model for our database, and each patron's document could include their loan book and personal information appearing conveniently at first glance. However, we have to consider the changes in book information, such as new edition, author details, consistent updates though. 1 second. Consider consistent updates, but with flexibility of dynamic, ever-expanding data. So yes, this is just our concept example. There we go. Here we go. Let's put this as an example JSON. There we go. And so, yes, this is our concept example for a library and managing books and patrons for relational and document models. So to be able to solidify our understanding for our concept, let's go over a practice problem. So we are tasked with implementing a feature for a new book club with a library application. So we're focusing on a feature for a book club library application. Where users can have many-to-many relationships with books. Users can have many-to-many relationships with books, meaning desires such as genre, author, or publication dates, just to name a few. So what we need to do is that one book can be favored by many users and one user can favor many books. One book can be favored by many users and one user can favor many books. And for us to be able to develop the schema in order to solve this problem is that the first thing that we need to do, let me just use a different color. One, we need to identify the relationships with the data and users. And then also, you need to implement the correct database. So in the first step, we need to discern if the data can be organized in a structured format. If so, then we go relational. If not, document. And once we have decided exactly based on the context within our domain over what we need to put in for the database, we are going to see if we can actually organize our data. Well, since we only have a book that we are organizing based on users, and those users and books can be associated with each other, we can build a table as a result, such as, for instance, we can do well, you can put an ID for a specific user. We'll have the user's name, the book title, genre, and then etc. And yes, we can make a viable table out of this. So yes, they can all have different cells and rows and columns. Since we have many-to-many relationships, that's the key. Many-to-many relationships. It's also structured data. We know what goes in and what comes out. We already know that we'll have a user, their name, their book title, and genre, and that can actually be associated as well. So we will be implement a relational database based on context and domain for our given problem. So what we need to do is that in this example, we need to create a table called favorites to handle the many to many relationships. This table would have IDs and foreign keys that also pertain to the user's name, the book title, and their genre at the same time. to enable a simple and efficient way to manage the relationships. Create a simple and efficient way to manage relationships, since we deal with many to many. Since we are dealing with many to many relationships with data. And so yes, let me just see if I can expand upon this. And I am going to have screenshots already labeled and given to you folks, and links in the description that will be downloadable, so you can download the notes for your reference as well, along with the practice example that would also be coinciding with each of the videos that we were making. So yes, that'll be over here. Now, for us to be able to solidify our concept understanding with the historical application of different forms of databases, we are now going to be continuing our example of libraries by focusing on a library book inventory. Now, the library wants to add a feature for tracking multi-genre categorization for books. So, the library wants to add feature tracking for multi-genre categorization for books. Each book can belong to multiple genres. Each book can apply and belong to multiple genres, and each genre can encompass many books. So we already know, just based on what they were requiring, we have a book, or any book, apply to multiple genres, or each genre to many books. It looks like that we have a many to many relationship. Here. Sorry about that, just have to clean that up for that bug. And then what this already signals to us is that we still need to abide by our following steps. Is that one, we need to identify the relationship type which we already done up here. And then the latter part, there we go. Implement the correct database. So when we've already identified many to many, that's already signaling to us we need to decide the proper database, relational versus document, and it looks like many to many refers to relational because it's structured, organized. Let's go over here. It's structured, organized, and can create multiple and unique IDs. There we go. And then we implement the correct database, which we already know is going to be the relational database. So similar to the book club feature, we can have the same type of table that we have. So we can have an ID, we can have a book title, book genre, and this table can refer to book genres. Refer to book genres. And then we can apply multiple categories. So let me just put this up. Can apply to multiple categories for our relational database. And so this is just our second example of what we would do within adding in our library book inventory. Let me just move these choices up so that way you folks can actually see all together. And I'm going to need to move this. There we go. Actually, there we go. I'll just zoom out as much as I can. And then, all right, well, never mind, I gotta do this. Refer to point number 1. And just zoom in for you folks. There we go. And so, yeah, this was the historical context between relational and document databases, and given the full encompassing scope and thinking through how to apply the correct database depending on the context and domain that we are dealing with. So yes, thank you very much for taking time to watch this. If you found this helpful, be sure to like and subscribe, and feel free to. And if you have any other questions, please feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.